Welcome back to part 2 of our truss calculations here for POE. What we're going to really get into now is being able to calculate what type of tension or compression each member of a truss is. We have all the necessary information. We're going to go slow and take as long as it takes. So what we have here then is, here's a simple truss for us. Notice that it's pinned over here on the left, and on the right we've got a roller. So here's where it's pinned, and over here we've got a roller. Method of joints, not jokes. Use cosine and sine to determine x and y vector components. And we've talked about that. Label the triangle in the side that's the opposite. The side that ends up being the opposite is the one you're going to use the sine. The one that ends up being the adjacent is the one you're going to end up using the cosine for. We automatically assume all members to be in tension. All right, we automatically assume all members to be in tension. A positive answer will mean the member is in tension. A negative one is going to give us compression. So if our answer is positive, we say it's in tension. If we get a negative answer, it means it is in compression. Next, as forces are solved, we need to update our free body diagrams. This is our project here. Here's the one we're going to be working on together. The first thing we're going to go through here then is we're going to go through here and try to find the angles. And as I've taught you, we're going to label the sides of the triangle. So this is my angle. So this is the hypotenuse, this is the opposite, and this is the adjacent. So if I want to find the angles, they don't give me the hypotenuse, but they do give me the opposite adjacent. So what that turns into be then is the tangent function. And we can go about finding the angle here by simply saying the tangent of theta equals the opposite, which is 4 over 3. Well, that's all great and dandy, but how are we going to find theta? We typically use theta or some angle to find the missing side. Well, we use what's called the inverse tangent. And what that tells us, that's theta not 0, is that theta is equal to 53.1 degrees in this case. So the other angle, now we're doing the far right angle. Again, we have 4 and 7. Well, let's label the triangle. This is my opposite side. This was the adjacent, and that was the hypotenuse. So that takes us to the tangent, because it's TOA, opposite adjacent. The way I'm going to go about doing this then is I'll say the tangent of theta equals the opposite, which is 4 over 7. That means the inverse is that. So what we find out then is that theta is 29.7 degrees. So let's take a look at our picture here again. We know that this one over here is 29.7 and that this one over here is 53.1 degrees. Well, now that we've done that, our next step is going to be to draw a free diagram at each pin. Alright, draw a free body diagram of each pin. So what we've done here is we've kind of broken this all up and we've written a free body diagram. I want you to imagine now that what we're going to end up doing is we're going to end up isolating these sections. We're going to solve these as 4 different problems along the way, using what we know and slowly filling in the rest of the bits of the information. Well, we're going to label these sides, these members, as this is the distance between A and B, so we're going to call it AB. This is the member between AD, so we're going to call it AD. This is between B and D, so we call it BD. This is between C and D, so we call it CD. And then this one's between BC, so we call it BC. So that's what we're doing right now, is we're going to, again, break this down into its different members so that we can break this into a simpler problem. We can't do them all at the same time. Okay, we're going to go pretty fast here so that I can get this all in. But what I've done is I've left the computer part of the first part here, the sum of the forces in the y direction. All right, so if we break this down now, we're going to have, we know that the upwards, the y direction, has to be equal to this 350. Well, I know then that our y vector, this is truly AB sine of 53.1 degrees. That's what this one right here is equal to, this y component. Why? Because this is AB is the length. I don't know what AB is. Call it. And yesterday we were saying it was F. All right, whatever number this is, right now we're going to call it AB. All right, this force, AB, and it's the y component. Well, if I label my triangle, it's this one over here. That is the opposite. So I'm using the sine function. So I get 53.1 degrees. I do know what AB in the y direction is. That's this right here. That's the AB in the y direction. I'm sorry, the RAY. I know RAY is the reactionary force at A in the y direction is 350 plus my AB sine of 53.1 degrees equals 0. And then as I start to solve for this, I get AB sine of 53.1 degrees equals 350. Actually, it's a negative now when I take it to the other side. So that's negative. And divide by the sine of 53.1 degrees. And we get AB is equal to negative 437.7 pounds. And I've rounded that to 437.7 pounds. So I'm going to go in here now and I've updated it. I've said that AB here is 437.7 pounds. From this point, I'm going to go ahead now and choose point C over here. This is probably going to be the next easiest. I've got two unknowns. I don't know BC and I don't know CD at this time. So as I go on, here we go. Here's what it'll be. Correction, I haven't quite found the X value here yet. What we're going to do is we have to find the sum of the forces in the X direction. And we know that it should be equal to 0 because the bridge isn't going to move. The truss isn't going to move. So what I've done here is I've started saying negative ABX plus AD. Well, why do we have this negative out here? Why do I have this negative here? Well, the reason we have that negative is because, remember, our answer for AB was negative 437.7 pounds. So when we come here, but we've listed AB as a positive 400. We're always going to put them down as positive numbers. The negative and positive, like in physics, tells us the direction. The negative and positive here tells us the compression, but we don't want to get caught up in keeping track of the negatives when we do that. When we go to do our math, we have to use that negative and realize that it's not just 437.5 pounds, it's 437.5 pounds, and it's actually negative. So I put this negative AB in here. What that gives me then is negative AB cosine of 53.13 plus AD equals 0. Well, this right here is going to turn out to be 262.5. And remember, I know what AB is. I simply plug that into there. 262.5 equals AD. So, oh, sorry, what I should have done is taken AD to the other side. Alright, so let's do that. AB cosine 53.13 equals negative AD. That's what I get when I take this to the other side. The negatives cancel out, and we get that AD is equal to 262.5 pounds. So, we go back, and we've plugged that in. We now know that AB is 437.5 pounds, and AD is 262.5 pounds. Well, now I'm going to go over here to point C. And I'm going to start with the y direction again. Well, as we look at this in the y direction, the reactionary force of C in the y direction, I do know has to equal to this 150 pounds. Because it has to be pushing down as hard as this is pushing up. So I know that's 150. Plus, all right, well, what is BCY equal to? Well, we know that BCY is equal to BC times the sine of, in this case, 29.7 degrees. So I'm going to be plugging that in for BCY because what I really want to know is what's BC. So I'm using a little bit of that substitution method from algebra. So we get BC sine 29.7 is equal to 0. I'm going to take 150 over to the other side, and that gives me BC sine of 29.7 equals 150. Well, divide by the sine of 29.7, and BC turns out to be, when I take that over, I get a negative 150. That's going to give me a negative 302.7 pounds. So BC is 302.7 pounds. Now that negative, what does that negative tell us? That negative again tells us that it's under compression. All right, that means it's being squeezed together at that point. So this is 302.7 pounds where it's being squeezed together. It's wanting to be compressed. Well, you can see I plugged that in here now. So we're slowly starting to find what our different components are here. We've got AB, AD, and BC. CD is the last one I'm going to do today. We'll finish up the other ones later, but CD then is the X direction. So that's going to simply be the sum of the forces in the X direction. Okay, real quickly I want to go back because some of you may be confused. This is what the computer got, and it's just a difference of rounding. For right now, we can say it was 302.7 pounds, and that takes us, updates us. I don't want to confuse anybody with that. Some of the forces in the X direction. Well, and the other difference I would make here with this is I would change this to a positive and make that negative, because we just found BC to actually be a negative right here, a negative 302.7. Again, we found it to be negative 302.7. So I think for simplicity, we're going to make this negative, and that should be a positive. Now, having said that then, again, we know that BC is this. So what is its X component? We know that BCX equals BC times the cosine of 29.7. So I'm going to be putting this in up here for BCX. So negative BC cosine of 29.7 plus CD equals 0. Well, let's move CD to the other side, and we get negative BC cosine of 29.7 is equal to negative CD. What do the negatives do? They drop out. So I'm going to get some answer here for CD. And that turns out to be 262.5 pounds. So now I just found this, and notice what we have right there. I've already put it in there, forgot to erase it. 262.5 pounds is what CD turns out to be. The last thing I'd have here then, this is the easy one, so I guess I'd go ahead and show it to you here. The sum of the forces in the Y direction, well, BD, right, BD is right here. BD minus FD, well, what's the force at D? The only force we had was 500 pounds. It's going down, so that's why they have it being negative. So BD minus 500 pounds equals 0. What does BD have to be? BD has to be pulling up with a force of 500 pounds. Right, so we have this tension force here then of 500 pounds. Well, I hope that was very informational. I know some of you are still really confused. I'm kind of at that time limit. We'll talk more about this in class, and I understand that this is going to be confusing for a lot of you. I'll catch you on the flip side.